Okay, we have this problem here. I haven't tried to solve it yet, so you are going to get to see the raw, uncut, problem-solving approach here. So we have a ball and it is thrown straight up from a ground with an initial velocity of 20 meters per second. We're going to assume air resistance is negligible because this is not a 300 level physics class, and we take acceleration due to gravity to be 9.81. Great, so we assume all normal stuff. So the first thing I'm going to do is I'm going to draw a picture of this, right? So we're going to have, no, I don't want to draw it in red though. We're going to have some little person here, assuming that its height is negligible. It is going to throw the ball up. Because there's no angle, I'm assuming that the ball goes straight up, and then it will come straight back down to the ground. I'm assuming that the distance between this person throwing it and the ground is negligible, so I can ignore that. I'm just assuming that this is ground level. So I'll make it so it starts at the ground and it lands on the ground. And I am going to label the velocity at the top here, and I'll explain why in a second. So the next thing I want to do is I want to list out what information is given to me and what information I am looking for. Notice that I haven't even figured out what I'm solving for yet. I'm just trying to break this problem down and figure out what information I am given. So what do I have? Well, I know that the ball is thrown straight up from the ground with some initial velocity. So my initial velocity is 20 meters per second. I know that the initial position of my ball is going to be 0 because it starts from the ground. And if I assume air resistance is negligible, right, we have acceleration due to gravity, and this is going to be negative 9.81 meters per second squared. It's negative because acceleration due to gravity is going in the negative direction. My velocity is positive because this ball is going upwards in the positive direction whenever it's released, right? And we can assume that we have just a normal coordinate system here. And that's all the information that I am given. So it wants us to find how high the ball goes, so the maximum height. It wants us to figure out how long it takes the ball to hit its maximum height. We want to figure out the total time the ball is in the air before it hits the ground, and we want to figure out the velocity of the ball right whenever it hits the ground. So there's 4 different things that it's asking us for. The next thing I want to do is figure out what type of equations I can use. Well, I know that this is one-dimensional because there's no angle, and it is a kinematics problem. So I'm going to write down the 4 kinematic equations, right? And we can just pull this off of the formula sheet that I have given you. So final is equal to initial plus my average velocity times time. We have our second kinematic equation where the final velocity is equal to the initial velocity times acceleration times time. We have final position is equal to initial plus your initial velocity times time plus 1/2 acceleration times squared. And we have the fourth kinematic equation where our final velocity squared is equal to the initial velocity squared plus 2 times acceleration times our change in position. So because this is given to me in a specific order, I assume that I have to solve this in this specific order, meaning that the first thing that I want to do is I want to figure out how high this ball goes. So I'm going to try to figure out what the y max is. What is the maximum height that this ball reaches. And I can pull out an additional little piece of information, and that is my velocity at maximum height. My velocity at maximum height is going to be 0. Okay? So if we think about this, we take a ball, we toss that ball up into the air. It has a certain amount of velocity whenever I release it from my hand. As this ball moves up in the air, it starts to slow down because of the acceleration pulling downwards towards the earth due to gravity. In order for this ball to turn around and start to head back down towards the earth, at its maximum height, the velocity has to be 0. That's because I have a positive velocity as it is moving upwards, and I have a negative velocity as the ball is moving downwards, meaning that at some point in time, this ball has to change direction. And if I think about, let's say that this is time and this is velocity, I start with some 20 meters per second velocity. It starts to slow down, but it's still in the positive, right? At some point in time, in order for me to get to the negative, I have to cross that velocity is equal to 0. And that happens at the maximum height. That's the turning point of this ball. So this means that I can use this extra information to try to solve the problem. So for this specific question, how high does the ball go? I know that my initial position is 0. I have an initial velocity of 20 meters per second. I'm considering my final velocity to be at that maximum height. I have the option of choosing what snapshots in time I want to look at, and I want to stop looking at this ball whenever it reaches its maximum height. So its final velocity is going to be 0 meters per second. I have acceleration, right, is equal to negative 9.81 meters per second squared. And I know that I want to find the final height. It's the final because I'm considering my initial condition to be when I release the ball and my final condition to be at the top of this motion, right? Because I'm only considering how high this ball goes. I'm not worried about the rest of it. I'm only thinking about these snapshots in time. So I want to go through and figure out which equations I can use. I'll change these to y's. That might be confusing. I apologize. I forgot what I was saying now. Oh, I want to figure out what kinematic equations I can use to solve for y final. So the first thing that I need to do is I need to figure out which equations have this variable that I'm looking for. So equation 1 has a y final. I could use that. Equation 2 does not, so I won't want to use that one. Oh, I still want it there though. Equation 3 has a y final. I could use that. Equation 4, technically this is final minus initial. I could also use this equation. The next thing I want to do, right, so I narrowed it down, I got rid of one of them. The next thing I want to do is figure out which equations have require a variable that I don't have. So for example, I have no information about time, meaning that I don't want to use this one, and I don't want to use equation 3. That's because it would leave me with two unknowns. I wouldn't know what my y final is, right? And I also don't know what my time is. I have two unknowns. For this third equation, I don't know what y final is, and I don't know what time is. I have two unknowns. I can't solve the problem simply. I could use a system of equations, right? So two equations with two unknowns, plug one into the other and solve it. But I'm trying to really simplify and make this the fastest approach possible. It's not going to seem like it. This is going to be a very long video. But whenever you're solving problems, you don't want to spend 20 minutes solving something that you could use with just one equation because you got stuck in a situation where you have to use a system of equations. So I need to use this fourth kinematic equation to solve the problem. So I have my final velocity squared is equal to my initial velocity squared plus 2 times my acceleration times my change in y. Let me make sure I have everything that's necessary. So I have a final velocity, I have an initial velocity, I have an acceleration, and I have part of my delta y. I'm going to replace this with final minus initial. And the next thing I'm going to do is I'm going to solve this so that I have y final by itself. So I am going to have final minus initial. I can divide by 2a. This is going to give me y final minus y initial. I'm going to flip it and move that y initial over to the other side. I'm doing a lot of algebra steps all in one time. If you can't do it in your head, that's okay. Take the time and work the steps out. Just make sure that you get to these, let's call them key checkpoints that I arrived at. So now that I have the variable that I'm solving for by itself on the left-hand side, I can go ahead and plug in my numbers. The reason why I want to have all of the algebra done before I start to plug numbers in is because there's a lot less room for error here. So let's say you make an algebra error. If I have variables, it's easy for me to go through this again and check myself to see where I made a mistake. If I start plugging numbers in and squaring stuff and getting decimals, it's going to turn into a mess. It's going to be very, very challenging to try to figure out where you made a mistake. So this is going to end up being y final is 0, 0, negative 20 squared over 2 times negative 9.81. And we get that the maximum height that this ball reaches is going to be 20 meters. So this is my solution. Y max is equal to 20 meters.